In a production electrolysis system, an emergency shutdown or depressurization procedure may be initiated for a variety of reasons, but the goal is always to safely bring the system pressure down to atmosphere so that the issue that triggered the shutdown can be addressed. However, a shutdown procedure like this introduces some challenges. In alkaline electrolyzer systems, a thin membrane separates the hydrogen and oxygen sides. These membranes have limitations in terms of the maximum differential pressure, or DP, that they can tolerate. When this DP limit is exceeded, they can allow crossover flow of gas or even rupture, creating a potentially dangerous mixture of gases. This DP limit is often on the order of 10 to 100 millibar. Equilibar valves are uniquely suited to balancing the DP in these systems. When used in a configuration shown in this schematic, with one valve on the hydrogen line and one valve on the oxygen line, with a shared nitrogen pilot volume, both sides can be brought down to atmospheric pressure while minimizing the DP. This schematic shows the setup for a proof of concept test, highlighting this DP control. A large 20-gallon tank and a smaller 5-gallon tank are pressurized with air. These tanks represent the oxygen and hydrogen sides of an electrolyzer system. We made these tanks different volumes, as in a real system, the oxygen side will have considerably more mass flow due to being a heavier gas. The DP gauge in blue measures the difference between the two volumes. A gray tank serves as the pilot volume for two Equilibar ESD back pressure regulators on each line. In this video, you can see this system in action. The square Wika gauge in the center shows the tank pressure in PSI, while the circular blue gauge shows the DP between the black and green tanks, also in PSI. You can see that as we slowly bleed down the pressure, the DP gauge shows that the two tanks are very closely balanced, with the DP peaking at around 1 psi throughout the depressurization sequence. It should also be noted that this setup does not require any closed-loop electronic controls. The balancing of these two tanks relies only on a shared reference volume, a purely mechanical solution. For more information on this and other applications of our valves within the hydrogen industry, visit equilibar.com.